Background music played in commercial venues is often used to define the mood of the venue, but also affects the emotion of the hosts and guests. There are several ways to evaluate such music pieces. However, rating with one or two pieces at a time will introduce inconsistency across ratings. Also, only music pieces used in the experiment are rated. Hence, we propose the use of the multi-stimuli ideal profile method, MSIPM. The ideal profile method, IPM, is a subjective attribute rating method that includes the most ideal stimulus in the list of stimuli. The ideal stimulus is not presented as the actual sensory object, but rather participants are asked to imagine and rate the given attribute as if there is the ideal stimulus. A variation of IPM, known as the multi-stimuli ideal profile method, involves the simultaneous comparison and rating of multiple stimuli on a single attribute. Authors have seen it used in foods and cosmetics, but can it be used for rating music? To check whether MSIPM is applicable to evaluate music pieces, we prepared 3 songs with 8 arrangement styles, including 1 virtual style for the ideal stimulus. Rating attributes were taken from the work by Taniguchi on relating musical impressions to emotion. Participants were asked to listen to arrangements using the app shown below. After clicking on A, B, or C to choose a song, participants were able to switch between 7 music styles. They were asked to rate each stimulus on an 11-point scale from 0 to 10 on given attributes. When ratings of one song was completed, participants proceeded to the next song. The order of the songs is counterbalanced between the participants. Total of 11 university students and postgraduates took place in the experiment. Principal component analysis was applied per participant. Here, results from participant number 4 are shown. The left figure shows attribute space, where stimulating and casual are pointing towards the left, and depressed, calm, and tender are pointing towards the right. The figure on the right shows stimulus space. A, B, and C show 3 songs, and numbers from 1 to 7 represent arrangement styles. AID, BID, and CID are ideal stimuli. We can overlap 2 figures to see the relation between attributes and stimuli. We can see, for example, stimulus A3 on the right is located at depressed, noble, and serious. On the opposite side, stimulus B7 can be explained to have a caprice and stimulating character. Since some participants were not able to fully use the attributes, multidimensional scaling was applied on Euclidean distance between raw ratings from all participants. Because participants 1 and 10 on the right are placed farther apart from the other participants, those 2 first-year students seem to be outliers. After excluding the outliers, group configuration can be obtained by applying PCA on average ratings. We can see that there are 2 groups of arrangement styles, and the ideal arrangement is configured in the middle upper position within the larger group. Because ideal stimuli are configured closer to arrangements 1, 2, and 6, we may be able to tell a human arranger to use them as a point of reference when we want to further arrange the songs. Through this feasibility study, it was shown that MSIPM was applicable to evaluate arrangements of music pieces. Experiences in participating in experiments and fluency in attributes affected the ratings. The difficulty of the experiment was not a problem for most of the participants, thus making MSIPM one of the attractive options for conducting a music listening experiment.